Hello everyone, welcome back to my YouTube channel. So today we are going to solve the 12th problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3539. Find sum of array product of magical sequences. So let's read the problem statement. You are given two integers m and k and an integer array nums, right? A sequence of integers sequence is called magical if sequence has a size of m, right? So one m value is given to us, right? So here let's say this example number 3, if you see m is equal to 1 given to us, right? So a sequence of integer sequence is called magical if a sequence has a size of m. All right, let's say this sequence has a size of m and m is nothing but 1. Okay, now here sequence at I, right? This value sequence at I value, so this value should be from 0 to less than nums dot length. So here this is my nums array, right? So nums dot length is 1, right? So 0 to less than 1 simply means only 0, right? Simply means only 0 in this case, example number 3. 0 to less than 1, right? 1 is the value of this nums dot length, so only 0. So here this sequence of I, it is denoting nothing but the indexes which are there in my nums array. So only 0 index is there as of now, right? This is nothing but length, but only 0 index is there, right? So this sequence of I value, right, the values that I need to fill here, these are nothing but the indexes from my nums array, right? All these indexes I have. Clear? Right? Now here we have only one, right? So let's use that. Let's use this 0, right? Clear? Done. Now it is saying the binary representation of this 2 power sequence of 0 plus 2 power sequence of 1 plus dot 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 plus 2 power sequence of m minus 1 has k set bits. So m is nothing but, in my case, it is 1, right? It is 1. So 2 sequence 1 minus 1, it is nothing but sequence of 0, right? So until only one value will be there, right? If you see the sequence, only one value is there, right? M is 1, right? Only one value is there in my sequence array. So that simply means what I need to do, my starting value, right, 2, and here sequence at 0 index. So sequence at 0 index, we have nothing but 0, right? Sequence of 0 value, right? Only one value will be there, right? So if my m is equal to 1, that simply means until 2 sequence of 0, right? If my m is equal to 2 means 2 sequence of 0, right, plus 2 sequence of 2 minus 1, 1, right? So this is for m, right? So in my case m is 1, right, as of now. So that simply means 2 of sequence of m minus 1 until here only, right? 0. So sequence at 0 index, but we have 0, so 2 power 0 is nothing but 1, right? So 2 power 0 is nothing but 1. And how I'm writing 1 in binary form? So in binary form, bits we represent it like this: 1 2 4 8. So how I'm writing 1 in binary form? I'm writing 1 like this in my binary form, right? Clear? This is done. Okay, so now see, the binary representation of this has k set bits. So how many set bits are there in this representation? Only 1, and 1 is nothing but, it is equal to k value that is here, right? So that simply means that this particular sequence, right, a sequence of integers, is called magical. So this particular sequence is nothing but magical. Clear? This part, right? It is a magical, right? So only one possible sequence we can form from this example, right? because m is equal to 1 and here we have just one element, right? Okay, so only 28 we have. So here if you see, the output is 28 in this case, right? So let's read the problem statement further. The array product of this sequence is defined as the final answer product of all the sequences that we have. So in this case only one. So but if we have multiple sequences like this, so I have to just multiply all the sequences, right? So sequence at 0 into sequence at 1, like this is what I need to do, right? In the end, clear? We have to just find the product, right? The array product of this sequence is defined as this. Okay, clear this part? Done. So okay, this is done. So this is nothing but for this one, right? Nums at 0, nums at 0 is 28. Only one sequence I'm taking. The array product of this sequence, only one sequence. I'm not taking multiple sequence, only one sequence. Now we have multiple sequence, right? Only one sequence we have, right, as of now. So in this we have to calculate the product of all the elements. But if we have multiple sequences, then we have to calculate the product of all these sequence one by one, and then we have to do the addition among them. So that is what written here. They return the sum of the array products for all the valid magical sequences, right? Since the answer may be very large, we have to return it modulo 10 to the power 9 plus 7, and a set bit refers to a bit in a binary representation of a number that has a value of 1. Okay, clear. So I hope that this problem statement is clear, right? So the array product of this sequence is defined as this particular sequence, only one sequence. So in this we have to multiply, add 0 index, but we have 28, right? So 28, and we don't have a sequence of one, sequence of m minus 1, because length is 1 only, so only one will be there, right? This. But if we have multiple sequence, then all the sequence we have to find out the product, and then we have to do the addition, right? Sum of the array products for all the magical sequences. This is what we need to do, right? So I hope that this part is clear, right? Okay, so here the only magical sequence is 0, this, right? That's it. And if you see the constant size, so k and m value is small, right, until 30. Nums dot length value is also from 1 to 50, and nums of I values from 1 to 10 to the power 8, right? All right, so this is our problem statement, right? So now let's understand with this example, little bit big. Okay, let's see this example, right? So in this case, m is equal to 2. That simply means and nums total length is also 2, right? So it means we have index in 0 and 1, right? So here in this case k value is 2, right? Okay, so first of all, we need to form a sequence, right? So in a sequence, right, the length is going to be of m, right? So two values I can fill here, right? And the values that I can fill here, I have the option to use 0 or 1, right? Because in the sequence, right, in the sequence I'm just filling the indexing, and these indexes are nothing but the indexes of nums, right? So in nums we have just 0 and 1, so only these indexes I can use. So I can use 0 1, I can use 1 0 here of this length we need, right? And here these values can be repetitive, right? I can choose one index two times as well, like this is also valid, right? So these are the different choices I have. Okay, done. Now here if I choose this, right, so first thing that I need to check, if for a sequence to be magical, so I need to do this 2 power 0 plus 2 power 1, right? Okay, so what is the value here? 2 power 0 plus 2 power 1, this is nothing but 3. So in 3 how many bits are set? So how we write 3 in binary form? 1 2 4 8. So we write 3 like this in binary form. So number of bits set is 2. So k is equal to 2 now. So I'm going to say this is magical, right? So if this is magical, definitely this is also magical. 1 comma 0, I just changed the order, right? Just change the order, but this is another sequence, right? So in this case this is also magical. But tell me, this is magical 0 0. So here this is nothing but 2 power 0 plus 2 power 0, that is nothing but 1 plus 1, that is nothing but 2. So if I write 2 in a binary form, I'm going to write like this 0 0 1 0, right? But only one bit is set, so that simply means that this is not valid. right? This is not valid sequence. This is valid sequence. So here I'm going to write it like this. uh, 2 power 1 plus 2 power 1, right? This is nothing but 2 plus 2 is nothing but 4. And how I'm writing 4 in binary form? I'm writing 4 like this: 0 1 0 0, right? Only one bit is set, so this is also not magical. So only sequences which are magical are 0 1 or 1 0, right? Two are valid, right? One is 0 comma 1 and one is 1 comma 0, right? These two are valid sequences. Okay, so now these two sequences are valid, right? So at 0 index, what we have? At 0 index we have 2, at 1 index we have 3, at 1 index we have 3, at 0 index we have 2. So I told you that we need to do the multiplication of these two and then we have to do the addition. This is what is asked in problem statement. So 2 into 3 is 6 plus 6, that is nothing but 12. 12 is my output. That's it. Clear? Right? Let's see one more example. Let's see this example now. So again, similar type of example. So m is equal to 2, right? So of 2 length you need sequences of 2 length, right? And here this is nothing but a sequence, and m value is equal to 2, so length is 2. Now you can only use 0 and 1 index, right? So here again you have two options, four options. You can use 0 0, you can choose 1 1, you can choose 0 1, and you can use 1 0, right? These are the different ways to choose, right? Clear? Done. Now here in this case, uh, can you choose this 0 and 0? So if I write it like this, 2 power 0 plus 2 power 0, this is nothing but 1 plus 1 is nothing but 2, and 2 means something like this: 0 0 1 0, right? In the binary form only one bit is set. So here in this case k is 1 na, right? So that simply means that 0 comma 0 is a valid sequence. Same way 1 comma 1, if you calculate 2 1 2 power 1, that is nothing but 4, and 4 you are going to write like this. This is also a valid sequence, 1 comma 1, right? But here if you see this 2 power 0 plus 2 power 1, that is nothing but 1 plus 2 is 3. So if you write 3 like this, so that is nothing but 2 bits are set. So this is not a valid sequence. Same way this is also not a valid sequence. So only these two are valid sequence, right? So here if you write this 0 index we have 2, this 0 index we have 2, this 1 index we have 3, this 1 index we have 3. So if you do the multiplication of these two, right, first we need to do the multiplication. So that is the meaning of this line. The array product of a sequence of this sequence is defined as nums sequence of 0 into nums of sequence of 1, nums of sequence m minus 1, right? So that's the meaning of this. So we are going to get 4 here, we are going to get 9 here, right? And then after that what we need to do? Return the sum of the array product. So sum of the array product is nothing but 4 plus 9, that is nothing but 13. So 13 is the output. So I hope that this part is clear. Okay, so these are the few examples. All right, so in today's problem I'm going to use a few things like this Fermat Slater theorem, right? Factorials. I am planning to use this fast exponentiation, right? I'm planning to use this binomial coefficient as well, and this is important are modular inverse, right? Using this Fermat Slater theorem, right? So in this particular video, right, problem number 2338, right? If you see this video, right, the number of ideal arrays, right? So in this problem I have explained all these terms in very detailed manner, right? So you have to watch just I think 25 to 28 minutes of video. Okay, initial 25 to 28 minutes. You can skip few parts, but you will find out the definition of all these terms: binomial coefficient, what is modular inverse, why there is a requirement of this, what is this Fermat Slater theorem. So I have given the examples and definitions, right? In this video also I'm trying to cover, but not in much detailed manner, but I will try to cover. You can watch this you can watch the current video, and then if still need, then you can jump to this one, right? But first you can see the today's video, right? And if you still have any doubts or if you want deep understanding, then you can also take a look at this particular video, right? I have explained all these terms, right? Okay, so now let's understand how we need to solve this problem, right? So here let's take this example, m is equal to 2, k is equal to 2, right? M is equal to 2, k is equal to 2, and my nums array is like this, 2 comma 3, right? Okay, so here see how I'm going to solve this problem now. Okay, so here first thing, we need to form the sequences, right? We have to form the sequence, and we know that the length is going to be 2 only. Okay, these are nothing but, let's say, give index 0, index 1, right? And these are the elements that we need to use, right? Here if you see, when I was doing this, right, 0 0 and 1 comma 1, so here I'm just using these numbers only, right? So if you see, in this particular sequence I'm using 2 times, right? 2 times, and here in this particular sequence I'm using 3 2 times, right? Only these are valid, right? Clear? So here what I'm going to do, let I have to use this 2 and 3 only. These are the only options that I have to use, right? If I give the indexing 0 and 1, that simply means that this refers to these numbers only, right? So in my final output of sequences that I'm going to create, right? So in that particular outputs, I may use this 2 0 number of times, right? I may use this 2 one number of time in one particular sequence, right? I may use this 2 times in one particular sequence, right? This is what I'm saying, right? So I may use this 2 times, right? This 2 value. I may use this 2 just one number of time, right? I may skip it. I may skip it. I may never use it, right? Clear? Here also, one more thing, that I can use this to at this particular place, or I can use this to at this particular place, right? These are the two ways that I can show, right? So actually, right now size is very small, right? Only 2, so I am able to represent it like this. But there is one formula to calculate this. NCR, this is nothing but binomial coefficient. This is how we can find out that how many total number of ways in which I can place this 2, right? So the formula for this one is nothing but n factorial, n minus r factorial, and r factorial. So number of ways, right, we can have this r in total n, right? Or you can say number of ways to choose r combinations in n places, something like that. Okay, so here if you calculate this, n is nothing but 2, right? And r is nothing but only 1, right? I'm finding out one place, how many ways in which we can choose one place out of 2. So n minus r 1, and here also 1. So this is nothing but 2 factorial is nothing but 2, and 2 factorial 2 minus 1 factorial is nothing but 1 factorial, 2 minus 1 1, and 1 factorial is nothing but 1 into 1. So these are nothing but 2 ways, right? So this is the formula that we need to use. Okay, so here also if I give you some, let's say this example, right? So 2c2, right? Number of ways to choose 2 places out of 2. So if you calculate this, 2 factorial, and here 2 minus 2, 0 factorial. 0 factorial is nothing but 1. Here 2, here 2, right? So output is 1. So only one way, right? So here you are seeing just one way, right? Here you are seeing 2 ways. Here you are going to see what? 2c 0, 0 ways, right? So 2 factorial, 2 minus 0 is 2 factorial, and this only one way, right? Only one way to show no 2, right? That's what you can say, right? 0 factorial is nothing but 1 only, remember it. Okay, so this is what we have to do. Then same way after that, from 3 also I have choices, right? Whether I want to use this 3 0 number of times, 1 number of times, 2 number of times, whether I want to use this 3 0 number of time 1 time or 2 time, whether I want to use this 3 0 number of time 1 time, 2 time, right? here it is not possible. If 2 is 2, 3 is not possible, but still I'm showing, right? So this is nothing but at every point we have choices, right? We have first choice whether I want to use 2, how many times, 0 time, 1 time, or 2 time. So 0 is the minimum, 2 is nothing but a total size, right? And same way here also for 3 also we have options. So this is nothing but a DP type of problem. Okay, so this is nothing but a DP type of problem. So now let's see how we are going to further solve this problem. But I hope that this is clear, right? Why I'm writing this NCR, right? So there is also one term for this, that is, if you see, this combinatorics, this term, right? So this term, right? Okay, so here, now for this calculation also, see, it is saying problem statement. If you see, these values are very big actually. Here if you see, since the answer may be very large, return it modulo this. Okay, so n factorial may be very large, so when we do the modular of this, right, so we have to do the modulo of this part also, this part also, but this is nothing but a 1 divided by this, right? So we have to, this direct modular is not possible. Okay, mod with this modular very big value, right? 1 divided by this is not possible, right? So there is some formula. So that formula actually comes from the Fermat's little theorem. So we will see that later on, but let's first understand this particular example only. I'm taking few variables, let's say mask, and I'm setting it to 0. So mask is nothing but it is showing that which current element I'm currently planning to use and how many times I'm planning to use, right? So I'm just going to store the frequency, and later on I will use it to see if there is any carry or not. Okay, so just make sure that in the starting this mask value is 0, right? And m value is equal to 2. That simply means that the size of array that I need to form, the sequence array, right? And you can say the remaining number of positions. So initially it is 2 only, I haven't filled anything yet. And let's say k is equal to 2, right? So k is equal to 2 means number of set bits that I want to find. And here let's say initially you are at index 0, right? So now here we have total 3 choices, right? Uh, I can in my output, right? Maybe there are 0 instances of this 2, right? Maybe in my output there is 1 instance of this 2. Maybe in my output there are 2 instances of this 2, right? So this is nothing but the frequency, right? Frequency of the particular element, how many times I'm taking, 0 times, 1 time, or 2 time this current element in my output, I is equal to 0, right? So few base conditions that we can check here is, let's suppose when my m value is equal to 0, that simply means that I have filled all the values in my output. Let's say this is output, so I have filled all the values. So in that case only the remaining number of values is going to become 0, right? So if this is the case, right, and one more thing, I will check that the integer dot bit count of this mask, right? If this becomes equal to k, right, in that case I will simply return 1. Okay, 1 output will be there, that simply means, right? And if let's suppose your m becomes 0, right, but same time let's say your I is also going to become 2, right? If this condition, first we are going to check this condition. If we are still not able to return anything, right, then I'm going to check if my I is already 2 or not. 2 means out of bound, right? Only 2 values, right? 2 index 0 1, and that's it. 0 1, and this is nothing but 2, so 2 means out of bound. So here I is equal to 2, or you can say I is equal to n, right, if you want. So that simply means you have to just simply return 0, that's it. There is no output further, right? So here let's see how I'm trying to use this thing to solve my problem, right? So here if I skip this, right, so first if I skip this, so current element I am not using, right? So there is no frequency that I need to add in my mask. So my mask, if I just do the right shift now, my mask initially is 0. So if I just do the right shift on this one, right, so again this significant bit is 0 only, right? So mask is still going to be 0 only in this case. M is still going to remain 2, K is still 2, and I is, this time I will say I is going to become 1. So here I can write it like this also: 0 2 2 1, right? 0 2 2 1, just so that I don't cover much space, right? And if I take this 1, so next time my mask value is going to be, first what I need to do, whatever the mask value, just right shift it with 1, right? Because I am trying to take some other element, previous element I have to ignore, right? So that is the only purpose. So previous element I have to ignore, the new element I am going to take. So I'm just going to do the right shift by 1, so still it is 0 only. So in this 0, just add the frequency of the current element, how many time I'm using it. So 1 time, so your new mask value is going to become 1. So let's say your mask is 1, right? And after that I am putting in this m value. So if I'm using 2 one time, so definitely the remaining space is just 1, right? This is new m value, this is a mask value, right? And k value, number of set bits. So k value, right? So previous time my mask was 0, right? My mask was 0, there was no bit set from the previous time, right? From the previous time there was no bit set, right? But now if you see how I'm going to update my k or new k, I'm going to update it as k minus the previous time what is the mask value, right? And I'm just going to check if the last significant bit was set during the last time or not. So it was not set, so mask and 1, so it was not set, so it is going to remain k only. So k value is nothing but, in this case it is going to become 2 only, right? This is nothing but k value. Then after that I is going to move to the 1 index, right? This is what's going to happen here again. Okay, this is one thing, right? This is one thing. Now in this case, if you see, again we have options, right? Now I can skip, right? So here m value, if you notice, m value is 1, right? So I can skip, only one blank will be there, right? Only one blank will be there. One I filled two, maybe here or maybe here, right? I filled one value, let's say. I need to count both, but still, let's say something like this, I filled one value. So now only one is remaining, so I can skip or I can take. Only two options I have here. So if I skip it, then next time in my DP, right? So first mask value, how I'm updating. So previous value of mask, I'm always doing the right shift by 1. So if I do the right shift by 1 of this one, so it is going to become 0 only, right? So here mask value is going to become 0, and now m value is still 1, right? My k value, in this case, what is going to be my k value? So now my k value, right? Previous time I have what? I have 2, right? So now new time k value is going to be uh, k is nothing but k minus previous time mask value. Previous time mask value was 1, right? So mask value was 1 and 1 and 1, so k minus 1 only. So k minus 1 is nothing but 2 minus 1, that is nothing but 1. So my mask value is 1 here, and this k value is 1 here, and now this value I is equal to 2, right? Indexing is 2, right? So now here if you see, in this case my I which is 2, right? But still if you see, this is my mask value is 0, my m value is equal to 1, and my k value is equal to 1. So my k is 1 and mask is, number of centimeters in mask is 0, right? So both are not matching. Then I check this condition, I is equal to m. So in this case if you see, it's not matching, we are simply returning 0 here, right? But now if you see here, if we use frequency is equal to 1, frequency is equal to 1, right? Of what element? The next element 3, right? Value is equal to 3 here, right? Here what is the value? Value is equal to 4. Why I'm writing 4? So that's a simple formula, right? So 2, there are two places, right? If you see here, uh, right here, there are two places. Out of two places I have to, how many one places I can find where I can place this 2, right? And 2 in how many positions? On 1, right? This was the formula that we are using, right? Something like this, right? This is another number of ways. So 2 into 2 is nothing but 4, so value is 4 here. Same way here, value is going to be 3 by 1, and I only placing one C here, right? So 3 is one time, right? And in how many ways? One way only, right? Only in one place I can put. So here we are getting 3, right? Okay, and here the new DP value, if you see, the mask value in this case is going to become what? So frequency is 1 you are using, so mask value is 1. Okay, when I'm going to write code, then it will get, you will get better understanding. All right, and here m value, so m remaining is 0, right? In this case, so 2 is, I have already 2 seen 2 now I'm trying to use 3, right? And here k value, previous time mask is from here k is 2, but mask was 1. So now new time k mask is going to become 1, k is going to become 1, right? We have already calculated k1 here. So k is only dependent on the mask, so mask is coming from top, so same thing I'm using here. And the index is going to become 2. So here index is going to become 2 base condition, but before that I'm simply going to return 1 because of this condition. So here if you see, this is nothing but your mask 1, so number of set bits in mask is just 1 if you write it in binary form, and k value is also 1, so both are matching, so you are returning here. So here value 3, here value 4, you have to just do the multiplication, 4 into 3, 12. So 12 is the output, so we have to do the multiplication here, right, in one part, and also if there is some other subtree, then we have to do the addition, right? So that's what we have to do. Okay, so these are the few things that we need to take care, right, as part of this problem. And there are many other concepts like this format stator theorem, right, all this stuff. So we will see those things as well, right, step by step. So let's write the code and let's see. Okay, so what you need to do first here. So here, first thing, let's take the mode value. So static, and here final long mode is equal to test per 9 plus 7, right? 1 2 3 4 5 6 7 8 and 9, right? Okay, so now here after that I'm just going to create few variables here only, int nums and int n. So I'm just going to pass the values of this parameter, okay, of this method, these parameters into this nums and n, right? So that these are globally defined in my class, not inside the method. So that's the only reason. So here I'm going to write this dot nums is equal to nums, and here this dot n is equal to nums dot length, right? This is done. Then after that, this is done. Okay, now after that what I'm going to do, here I'm just going to return, we have to return the answer in int format, right? And here in this I'm just going to pass the dp, and in the dp what I'm going to do here, I'm going to pass the mask, I'm going to pass m value, I'm going to pass k value, and I'm going to pass 0. 0 is nothing but the index, right? And just I will make sure that this, I will do the mode of this, right? Mode. Okay, this is done. Okay, and here this is done. Okay, so now how I'm going to write the code inside this, so I will write private and here long dp, and here I'm going to write int mask, and here I'm going to write int m, int k, and here I'm going to write int I. And now inside this few base conditions that I have told you, that if my m value is equal to 0 and integer dot bit count value inside this mask. All right, if this value is equal to k, then in that case you have to simply return 1, right? And here if I value becomes equal to n, then in that case simply return 0 here, right? And here we have to calculate the total value, right? So how we are going to calculate the total? So we have total two options, right? One is option one is nothing but skip this index, right? Skip this index. So if we are going to skip this index, so my total, I'm going to update it as total as, so here total and plus, and next time in the dp, so I told you that whatever the mask value, right, just do the right shift of that every time, so that we forget about the past result and we take care of the current ones. And in that we have to add the frequencies, but here we are skipping now, so no need to add the frequencies. So you can write mask divided by 2, or you can write like this, your choice. We are just going to do the right shift. Okay, so your choice, you can write anyway like this or like this, like this, oh, here. Okay, done, right? So let me just revert, uh, like this, right? And here, or like this, mask divided by 2, right? And then here you can pass the same m value, and here k value is nothing but k minus, right, whatever the k and previous mask. Actually it is depending on the latest last significant bit from the mask. So here and 1, right, least significant bit. And here just you have to increment the index I plus 1, that's it. And this is done. Okay, and this is done here, right? This is done here. And your total, I'm going to write it here like this, and overall I will just do the mode here. Okay, so that's what I'm planning to do here. So like this, mode, done, like this. Okay, this is your first option, right? Okay, so now after that, let's see what's going to happen. So this is one option, and option two is nothing but option 2 is nothing but you can pick 1 to m, right? We have these many options now, 1 to m, one number of frequencies, right? Copies of nums of I, right? So we have to check for all this, right? So here I'm just going to run one loop, int frequency is equal to 1, frequency is less than equal to m, and here frequency plus plus. Now here inside this new mask, how I'm going to calculate the new mask? New mask is nothing but mask divided by 2 plus frequency, right? And how I'm calculating the new k value? New k value is nothing but k minus, same way like above, k minus mask and 1. Okay, so this is how I'm going to get the new k value. And here I'm just going to check if new k value is less than equal to less than 0, then simply break it, right? No need to check further. Okay, and here after that, first let's calculate the value. So value, how you're going to calculate the value? So here we have to do the we have to calculate the power of, right, the particular number, nums of I, and raised to frequency, right? This is what we were doing, right? And here we have to do the number of combinations we have to find. So ncr, right, this is the thing that we have to find, ncr, right? So let's say this ncr is nothing but a method, right? So this method, in this method I'm just going to pass the m value and the frequency, right? So I'm going to do this, and I'm calculating the mode, right? So these are the things we have to pass, and then we have to just simply update the total. So total is nothing but total plus here the value that I'm going to get from here, right? So I'm going to pass that value here, and I'm just going to multiply it with what, this thing, same thing, right? So I can simply copy this, and here dp, instead of mask variable 2, here I'm just going to pass new mask. Here I'm going to pass the m minus frequency, right? M minus frequency. So if I'm using one time, two time, right? So remaining positions, how many remaining positions are there? Here I'm just going to pass, in place of k I can pass new k that I have calculated above. Then here I'm just going to do I plus 1. That's it. Okay, this is done. This is done here, and this ends here, and from here I'm just going to return what, total. This is what we need to return. That's it. Okay, this is done. Now the few things are pending, right? So what is this, how I am going to do this, and how I'm going to do this, right? So let's see that. Okay, so actually this topic also needs a separate video, but yeah, you can refer this thing, right? In this I have already explained everything. So we are going to apply some shortcuts here. Okay, so what you need to do first, so how I'm going to calculate this mode power, right? So here let's suppose I told you to calculate 2 power 31. So are you going to do like this, 2 into 2 into 2 into 2 into 2, like this 31 times, right? So it is going to be very big, right? Let's suppose 2 power 310. So are you going to multiply 310 times, or are you going to do this like this? So is there any shortcut to this, do this, right? So that we will see. Okay, so here let's suppose 2 power 5. So one way is to do like this, 2 into 2 into 2 into 2 into 2. So that is nothing but 36, 2 into 2, 4, 4 to the 8, 8 to 16, 6 to 32, 32, like this. And there is one shortcut now. If instead of this, can you solve it like this? So here, see, base is nothing but 2, exponential is nothing but 5. So exponential is not yet 0, right? So what you need to do, so you have to first do the half of this. So instead of 2 power 5, you can write it like this now, 2 power 2, right? This one part and this one part, 2 power 2, like this, right? So you have to just do the multiplication of these two things, right? You can write it like this. But since this is also, if you see, this is odd, right? So if this is odd, so whatever the result you have, right, this is the overall result you have, so you have to multiply this with the base also. Base is nothing but 2. So now this is same thing, not 2 power 5. I can write it like this, 2 into 2 power 2 into 2 power 2, right? This is done, right? And after that, again, if you solve this part further on, so this you can also, if you divide it with 2 again, right? So you are going to get 2 power 1, 2 into 2 power 1, right? This is what you are going to write. Okay, same thing, right? This part, same way, this part also you're going to write like this, 2 into 2 power 1. Okay, same like this. So here also, if you see, 2 into, now if you solve this part now, this part will be already solved. So here 2, here also, if you come this 2 outside, right? And inside this I'm just going to write 2 power base above 0 into 1. So this is same thing now, 2 into 2 4, here 2 into 2 4, and this 1, right? Same way, same thing here, it's going to happen. So just for representation I'm showing, but it's very fast. So here if this comes around, so in that case you have to just simply return 1, right? This is just 1. If base becomes 0, return 1. So if you return 1, then overall this result is 4. Same way, this is also 4. So 4 into 4, and here outside 2. So 4 into 4 16, 16 outside 2 is nothing but 32. So this will be very fast actually. This is small example, but if it's a very big example, right? If you do it for multiple times, n times, so then if you divide it in half, then you have to just solve first half, second half will automatically be solved step by step, like that. So that is the purpose of this. So now let's write the code for this one. Okay, so I'm going to say this is nothing but your modular exponentiation or fast exponentiation, right? So here private long mode power, and here long base, and here long exponentiation, right? And here if exponentiation value, if it is 0, then in that case you have to return 1. And here you have to calculate the half is nothing but, again I'm going to call this method mod power, right? Modular power. And here I'm just going to write base, and here exponential divided by 2, right? And here how I'm going to operate my result. So long result is equal to half into half I have to do, that's it, right? Half into half, okay? And you have to just do the mod with modulo, right? And here if exponentiation value modulus with 2, if it is equal to 1, then in that case you have to just simply update the result as result into base, and again you have to do the modulo, okay? And in the end you have to just simply return result, that's it, return result, okay? So this is for this mode of. Now here NCR, right? So NCR you already know, right? So we have to find this value NCR. So this is nothing but n factorial, n minus r factorial, and r factorial, right? So here we are just dealing with the factorials, right? So in our example, right, if you notice one thing, what we are calculating factorials of, we are calculating the factorials of these m values, right? Until 30, right? So total positions that I can fill, right? So that's what, right? So here in two places, right, I am filling the values, right? So I'm saying that how many ways I can place fill one value. So that is nothing but 2c1, but here this is nothing but total number of ways m value, right? So I can do one thing, I can pre-calculate the factorials value, right? So factorial value, how do we calculate? So 1 factorial is 1, 2 factorial is nothing but 2 into 1 factorial, that is nothing but 2. What is 3 factorial? 3 factorial is nothing but 3 into 2 factorial. So 2 factorial is 2, right? So 3 into 2 is 6. What is 4 factorial? 4 factorial is nothing but 4 into 3 factorial. So 3 factorial is nothing but 6. So 4 into 6, 24. Shortcut, right? So we can do like this. So let's write the code for that. Okay, so all these things actually I have already explained here, right? If you need the details, complete details, right? Definitions, examples, everything, it's there. I have covered in 25 to 28 minutes everything, okay? So that's it, right? So here private void, and here pre-compute factorials. All right, so here let's say I'm passing n value, right? So here factorial is nothing but here I'm just going to initialize new long n plus 1 until here I have to do, and inverse factorial also I need to calculate because of this Fermat Slater theorem, right? New long n plus 1, okay? So actually here we have to do the modular inverse, right? This n value can be very large, right? N factorial value, so we have to do the modular of this m mod with mod. So this thing is not possible. 1 by n minus r factorial mod with mod is not possible. Direct division, right? This is like this, so direct mod calculation is not possible. So what we need to do here, we have to write it in form of multiplication. So this thing I can write it like this, n factorial into, if this n minus r factorial goes to top, so I can write it like this, inverse minus 1. Same way in multiplication form, this r factorial, and here I'm writing minus 1. Then it is possible, mod with mod, okay? So like this. So modular inverse right here. So Now this thing, right, if this thing is very huge, right, so in that case we can write uh, the inverse, right, like a inverse mod of mod. We can, instead of -1, we can write it like this, a, and here mod -2 mod. I can make it positive by using this formula. Instead of -1, if I write mod -2, then if I calculate mod, then it will work, right? So this thing also I will explain in the video how it comes, right? So you can refer that. So here this is done. So inverse factorial also we need, right? So definitely here I need to fill some value, then I have to find out the inverse of that value mod. Okay, so that is why inverse factorial, right? So now here factorial of 0 is nothing but 1. Okay, and then here int I is equal to 1, I is less than equal to n, I plus plus, and here factorial of I, I'm going to update it as factorial of I minus 1 into I, that's it. And here complete mode I have to take, right? This is done. All right, and inverse factorial is also very simple. So first of all, inverse factorial of n, if I know the inverse factorial of n, so I will simply use the formula of this mod inverse. I'm going to go this method mod inverse, and in this I will pass the value, this factorial of n, the bigger value, right? So I will write the code for this. So here how we calculate the inverse factorial, so this is also explained in that video how this works with example, right? So here greater than or equal to 0, and here I have to do I minus minus, and here inverse factorial of I is nothing but inverse factorial of I plus 1 into I plus 1. Okay, and this complete, you can take the mode, that's it. So actually here what happens, so how you calculate the factorial of let's say I factorial or factorial of any number, right? So this is nothing but I into I minus 1 factorial, right? This is how you do, right? I factorial is nothing but I into I minus 1 factorial, right? 8 factorial is nothing but 8 into 7 factorial, right? Something like this. Okay, so now here instead of I, if I say I plus 1 factorial, so I can write it like this, I plus 1 into I factorial, right? Like this, right? Now if I do the modular inverse on both sides, right, like this, then what I will get, then after that I will get something like this, I plus 1 factorial modular inverse is nothing but I can say I plus 1 modular inverse into I factorial modular inverse, right? Okay, so here this I plus 1 minus 1, I can write it like this as well, I plus 1 here, right, instead of here, right? And same way if I plus 1 goes here, so I can write it like this, I plus 1, right, into the inverse factorial of this I plus 1, right, this thing is equal to this side, inverse factorial of I, right? So this is the formula, right, that I'm using here. Inverse factorial of I is equal to inverse factorial of I is equal to inverse factorial of I plus 1, inverse factorial of I plus 1 into I plus 1 into I plus 1. So this thing is explained in that particular video, so you can watch that, right, with examples. So this is done. And here NCR using pre-computed factorials we are going to do that. So here I'm just going to write private private long NCR and here int n int r, and here if the r value is less than 0, okay, or if r value is greater than n, in that case you have to simply return 0, otherwise you have to return the formula that I have derived, right? Factorial of n, then the inverse factorial, right? Inverse factorial of n minus r, right? And here you can also do one thing, you can write it like this, mod, right, into inverse factorial of r, and again you can do one thing here, again to the mod, right? Mod. Okay, this is done. This is how you need to do, right? And how you calculate this mod inverse, so let's write the method for this one. So here you can say private long mod inverse, and here long x, and here you have to just simply return mod power x, and here mod minus 2. That's it. Okay, so now we have written few things here. Let's see if we are able to pass the solution or not. Let's see first if we are getting some errors or not. So yes, there are few errors. Let's fix that. So line number 45, 46 and 47 as of now, right? Definitely we need to fix few more things. All right, so here fact, okay, so this I am taking here, fact is equal to normal and inverse fact. Okay, so haven't we defined this above? I don't think so in the class. So let's define this long and fact here, inverse fact, right? So let's run the code and see. So now this is line number 23. Okay, so variable total might not have been initialized. Okay, let's see if we have initialized this total or not. Oh no, so here I'm writing 0, right? Let's run it again. So see, we are getting this exception, right? Cannot load from long array because this dot fact is null, right? Let's see. Pre-compute factorial, right? This I'm calling, right? I am not calling, I think so. So what I need to do here, this is my method, right? So what I can do here, I can call this, right? I haven't pre-calculated all this stuff. So here, what is my method name? My method name is pre-compute factorial. So I can simply call this pre-compute factorials, and here I'm just going to pass the m value, right? So now I'm going to call this, and then definitely I'm going to do all this stuff, and I'm going to pre-calculate everything, right? So once I call this method dp, so inside this dp method, whenever I'm going to use this, right, so definitely all these values like ncr and everything, these are pre-calculated everywhere, right? So in this factorial of n I'm calling, and factorial of n I'm already going to call this method before that, so that I get the pre-calculated values, right? So now let's run it and see if we are able to pass the test case or not. So now all the test cases has been passed. Let's see if we are able to submit the solution or not, or if there is any requirement of memoization. So see, 453 test cases got passed out of 528. So we are getting time limit exceed error. So that simply means that we need memoization, right? So if you see in dp array we are passing mask, m, k and I. So only these four values are changing, right? So if for these four values I store the result somewhere, right, then definitely next time I can simply, if I get the similar type of pattern, I can get the result, right? So what I'm going to do, I can simply do one thing. I can store this in one key, right? I will store this in one hash map. So let's say map string and the output as value, my, I can say long, the output of this. And let's say this is method of my memorization array, and here new hash map, right? This is what I'm doing here. And all right, so this is what I'm doing here. Okay, and here let's generate the key. So string key for my version. So my key is going to be like this: mask value plus here comma plus m value plus this comma plus I will say my k value or comma, and then I will say my k value, right? Okay, why I'm writing plus here like this, okay, m, and then here comma, here I can say and my k value, and here I'm going to say comma plus my I value. Okay, all this stuff, let me just format it to see if it looks good or not. So yes, mask comma m comma here again comma, why I'm doing again comma here, so plus I can remove this now. This looks good now, right? So mask comma m comma k value, then comma, then I, right? So this is the key that I will generated, right? And whatever the value that I'm going to get here of total, I'm going to put this in my key memo, right? My map, right? Memo dot put this particular value uh, key and the output of this total, right? So here I'm putting this, right? And here before doing all this stuff, right, I will check if I have already stored the value of this one in the past or not. So here I'm going to write if memo dot contains key, this particular memo, right, contains key, this particular key, right, we are generating key, then in that case we have to simply return memo dot get, right, how we get the value of that particular key using like this, right? All right, so let's see if we are able to pass all the test cases or not first, if we are getting any error. So we are able to pass all the test cases. Now let's see if we are able to submit the solution or not. So nice. So see, we are able to pass all the test cases, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.